please continue to, if those of you who haven't written in, please continue to write in. And I'm going to ask Kara, if you're moving the slides, could you please move on to the next one? Thank you. So my name is Smita Chandra Thomas. I'm the founder and principal of Energy Shrink. It's a consulting practice specializing in decarbonization through high-performance buildings. Just a little bit of background so that you can understand where we are coming from. So my undergrad is in architecture and my master's is in building science from back in the 90s. And at Energy Shrink, we have consulted to a variety of clients, including the World Bank and the United Nations Environment Program, to the DC Public Service Commission, as well as DC DOE. And I'm currently writing a book on decarbonizing buildings for Wiley. That will hopefully be used in university courses. And I'm also an adjunct at the George Washington University. So in my past work, I've performed energy and envelope analysis on a variety of buildings, including the New York Times headquarters, Bank of America headquarters in New York. And we also performed analysis for the entire US building stock for EPA, excuse me, while I was senior manager at ICF International and the technical lead of their building energy analytics team. So at Energy Shrink, we have provided energy analysis on a few projects in this area, including the AstraZeneca headquarters in Maryland and all the way to a net zero passive house in Virginia. We've recently done energy models for library for the deaf and blind in Virginia. And we've also, we are currently working on a model for a Porsche showroom in New Jersey. So there's a lot of variety between individual buildings and policy and program work. We provide BEPS compliance services to several clients in DC and Maryland. And in this process of providing the BEPS compliance support, we came across some aspects that we feel are not so well understood. So that was really the genesis of this course. We wanted to create something to help improve the understanding of where we are going with BEPS in DC. So this is what we'll be sharing with you today. So I'll start us off with a couple of slides, and then my colleague, Kara Hausman, will take over after the first few slides. Next slide, please. So a couple of notes about Energy Shrink before we begin. Very briefly, we work with innovative clients on decarbonizing buildings, and our main office is in DC. We are a certified woman-owned small business because I started it, and both at the federal level and a DC CBE. We are also certified in Virginia, Maryland, and New York, and Massachusetts, actually. Next slide, please. So we provide analytics such as energy modeling for LEED, state codes, and BEPS compliance, which we are about to discuss. We also provide green building policy advisory and research services. And this combination of knowledge informs the services that we provide for energy analysis. So with that, I'm going to hand it over to my colleague, Kara Hausman. Kara is an analyst at Energy Shrink, and she has a master's degree in sustainability and has been working at Energy Shrink on climate action plans, training courses, and also green building programs for NYSERDA. Kara, over to you.
Yes. Hi, everyone. It's great to be here. I'd first like to go over a few housekeeping items before I dive into the main material. So this webinar, again, is being recorded, so just please be mindful of that as we continue. Participants will be muted during the presentation. And lastly, we will hold a question and answer portion after we get through our material today. So just please be sure to hold those questions for later on. We'll ask you to either enter those questions into the chat or Q&A section at the bottom of your screen, or use the raise hand icon, which is, I think, the React at the bottom of the screen as well. Then we'll call on you during that section. So this course has three main parts. First, we have DC BEPS requirements and compliance options, followed by a section on DC building codes and their current and future requirements. And this includes those that may be triggered by additions and alterations. And finally, we'll touch on the issues that the Department of Buildings is seeing most often with the building addition and alteration applications. So this material will be shared over 2 sessions, 11 to 1 today, and at the same day and time next week. So today we'll cover DC's BEPS requirements and what they mean in the long term, as well as give an overview of DC building energy codes and how they align with BEPS. So we'll cover in the rest in the second session, and that will include the areas, the codes that get triggered with those additions and alterations. And that includes those being undertaken for BEPS compliance. And we'll discuss the issues that commonly arise with those applications that are submitted to the Department of Buildings. As mentioned previously, just please hold your questions for the discussion period. And please note the slide number on which you have a question so that we can jump back to that easily. Also, if there's any questions in your mind that you feel like we should be covering in our next session, please add those to the chat as well, and we'll try to accommodate those in the next session as well. So the main reason we're holding this webinar is because DC is in its first compliance cycle of its building energy performance standards, also known as BEPS. So these standards are a legal requirement in DC. There's a benchmarking law and a disclosure law. So under the benchmarking law, buildings have to report their energy performance every year. And under the disclosure law, the reported benchmarking data then becomes public. So these laws were put into place to provide a pathway for DC to comply with the Clean Energy DC Omnibus Amendment Act of 2018. This was updated with the Climate Commitment Act of 2022. By law, DC must achieve carbon neutrality by 2045, and 75% of DC's carbon emissions come from buildings. So BEPS is the way to get DC to carbon neutral. Please keep this in mind as we discuss what to expect from BEPS moving forward. Currently, all buildings larger than 50,000 square feet are required to comply with BEPS, or they'll face those fines starting in 2026. This means that they will be fined based on their 2025 performance as reflected in their utility bills. And this further means that by now, they should have updated their buildings to get in compliance. And if they didn't, they have the rest of the year to do so. It's about 3 months left in this year. So let's start with an understanding of what are BEPS. So building energy performance standards, also known as BEPS, set energy performance criteria for buildings. The goal of BEPS is to improve energy efficiency and reduce greenhouse gas emissions. These are tailored to a specific location, climate, and also policy objectives. Typically, BEPS are integrated into building codes or energy regulations, ensuring that new construction and significant renovations also adhere to the energy performance benchmarks. These standards require improved energy efficiency for buildings. So they include setting minimum standards for various building elements, and this includes insulation, windows, and HVAC systems. And additionally, BEPS entail mandatory energy performance evaluations and different verification processes to ensure that compliance with the established standards. They also may include objectives concerning the utilization of renewable energy sources, and this encourages the adoption of those sustainable energy practices in building design and operation. Now, there are several benefits of BEPS, and by setting energy efficiency targets and standards, these contribute to lower energy consumption and operating costs for building owners and occupants. They also play a crucial role in reducing the environmental impact of buildings by curbing those energy-related greenhouse gas emissions. Additionally, energy-efficient buildings often offer improved occupant comfort and well-being, and this further enhances their overall quality and desirability. Examples of BEPS in action include regulations that specify energy usage targets for different types of buildings, and compliance with BEPS typically involves submitting energy performance reports and undergoing energy audits to ensure that buildings meet those required standards. Overall, BEPS serve as important tools in promoting sustainable building practices and mitigating the environmental impact of the built environment. So in successive BEPS periods, DC is requiring successively smaller buildings to benchmark. So if a building energy use is over a maximum limit set by DOE, buildings get a few years to then reduce their energy use and related emissions. So after this period, if they're still over that limit, they start getting fined. So as I said previously, buildings above 50,000 square feet started benchmarking data in 2013, and then had to report their data in 2014. In 2021, they were required to choose a compliance pathway, which I'll get into deeper a little later. So this pathway may have been a 20% reduction in energy use or a prescriptive pathway that requires a fixed set of measures. So whatever pathway the owner selected, they got nearly 5 years to meet their goals. And if they fail, they will start getting fined up to $10 per square foot in 2026. So that's a significant financial incentive to reduce that energy use. And over time, you'll see that similar cycles will kick in for smaller buildings. Now, if you look at the image to the left, you all may be quite familiar with that, with the big green arrow depicting the BEPS periods. However, what's not that clear to many owners is that this only represents the first cycle for each building size category. The fact is that each successive 5-year BEPS cycle for any given building must be tighter in order to achieve that carbon neutrality. So we should expect this updated standard for BEPS every 5 years. So for example, if a multifamily building had to get a BEPS score above 66 in order to comply in 2021, it will most likely, if all goes as planned, require a much higher score in the next cycle to be considered within that compliance. So if a building required 20% reduction in energy use to comply in 2026, it would require a similar reduction in every cycle, every 5 years, until it reaches that carbon neutrality goal. And because it's expensive and disruptive to upgrade a building every 5 years, what we need is comprehensive roadmaps to achieve carbon neutrality for each building from the outset, so that the upgrades can be phased in intelligently over the next 20 years to meet these DC goals. Now, it's one thing to plan ahead and another to make a deeper cut right away. So this table here shows the accelerated savings recognition option of BEPS, which I'll get into a little later. And the benefit of deeper cuts early, as we saw on the beginning slide, are that we will start to reduce those cumulative emissions. So DC really incentivizes these savings by considering a building that achieves deeper savings from the outset for automatic compliance in the next cycles. So the deeper the savings, the longer the period for which the building is deemed to be in compliance. So in the BEPS program, there are several compliance pathways available for building owners. And these pathways offer that flexibility in meeting the program standards. So first we have the performance pathway. Here, a property aims to achieve a significant reduction in its site energy use over the BEPS cycles. And the goal here is to decrease that energy consumption by 20% compared to a baseline period or benchmark. And next, we have the standard target pathway. So here, building owners are provided with standardized energy performance targets based on the building type, the size, or the occupancy. Next, we have the prescriptive pathway. So this offers a set of predefined measures and requirements that building owners can implement in order to achieve that compliance. And lastly, there is the alternative compliance pathway. Here, building owners may propose alternative compliance methods or strategies, and these deviate from the standard pathways that were just mentioned above, but they still would achieve the energy performance outcomes. So this pathway allows for innovative approaches to demonstrate equivalent or superior energy performance compared to the standard pathways mentioned previously. Again, these compliance pathways offer building owners a range of options to meet the BEPS requirements, allowing to choose the best approach for their building. So we'll dive deeper into these pathways in the coming slides. So the performance pathway is open to all property types and allows building owners to implement measures of their choosing to reduce that energy consumption. So buildings again must achieve a 20% reduction in site energy use. So let's say a building has a baseline site EUI of 100, and over the course of the compliance cycle, it reduces this to 85 by installing a lighting upgrade, let's say. However, this only resulted in the building achieving a 15% reduction in energy use. Therefore, this building would not be compliant under the performance pathway. So it would need to reduce the EUI to at least 80 in order to be compliant here. So energy efficient measures may include upgrading building systems and equipment to more energy efficient models, optimizing operations and maintenance practices, enhancing insulation and air sealing to improve building envelope performance, and implementing advanced controls and automation technologies to better manage energy consumption. So requirements for this pathway include submitting a pathway selection form, a completed actions report, and a district benchmarking report. Next, we have the standard target pathway, and this again is for buildings in a high performing property type group. So this is where the site EUI is less than 20% away from the standards. So this table here, which is found in the BEPS compliance guidebook, lists the property types that fall into this category. So these refer to property types where the local standards or Energy Star scores are higher or more stringent, I guess, compared to the national median scores. So for example, if the standard for an office building is 72, a building following the standard target pathway with a score of 68 would have to raise its score to at least a 72 by the end of the cycle in order to meet that compliance. And similar to the performance pathway as previously discussed, building owners can choose the measures they think are best here for achieving that reduction in energy consumption. And also similar to the performance pathway, requirements include submitting a pathway selection form, the completed actions report, and a district benchmark report as well. So by achieving the designated Energy Star score or site energy use target, properties demonstrate their commitment to energy efficiency and environmental sustainability. And they also benefit from reduced energy costs, improved building comfort and functionality, and enhanced market competitiveness. So the standard target pathway encourages property owners to adopt best practices in energy management and invest in measures that yield long-term benefits for both their properties and the broader community. So unlike the performance-based pathways that were previously discussed, this prescriptive pathway is an action-based compliance method. So here, properties commit to completing specific actions outlined in agreement with the DOEE. So these actions are really tailored to the property's characteristics and energy consumption profile. So simply put, as long as building owners successfully implement the approved measures by the DOEE and meet all of those reporting requirements, the building will comply regardless of its energy performance. So this pathway is broken into 4 stages, which are noted in the graphic here, each with specific requirements. So phase 1 requires a pathway selection and a completion of an energy audit. Phase 2 requires owners to submit a comprehensive plan, which outlines the implementation of those energy efficiency measures. And this phase also requires an operations and maintenance plan. So this can include regular maintenance activities, system inspections, and operational adjustments to optimize the energy performance over time. Next, phase 3, also known as the implementation phase, takes place once the action plan is approved by DOEE. So requirements here include an implementation report and supporting documentation to verify that the measures were installed as approved. And lastly, phase 4 involves an evaluation of the building's performance after implementation of the measures, and this makes sure that they are working as predicted. So this phased approach facilitates transparency and accountability, which allows the DOE to assess compliance with program requirements and provide support and guidance throughout as needed to ensure those successful outcomes. So lastly, there's the alternative compliance pathway, also known as ACP. So property owners here have the flexibility to achieve compliance through customized approaches agreed upon with the DOEE. So this pathway allows properties to meet or exceed energy savings targets equivalent to those set by the principal pathways that were previously discussed in ways that may better suit their unique circumstances. So this provides an opportunity for buildings that want to pursue innovative ideas for deeper savings. So one form of this pathway is the accelerated savings recognition option. So this applies to deep energy retrofits completed during the current BEPS cycle that surpass the requirements of the current compliance cycle. So properties achieving significant savings during BEPS 1 may be granted compliance for future cycles. Another option includes the extended deep energy retrofits option. So this offers an alternative pathway for properties experiencing financial distress due to COVID-19. So qualifying properties can submit and implement a deep energy retrofit plan aimed at achieving a 40% reduction in site energy consumption by the end of the second BEPS compliance cycle. So in exchange for committing to this increased energy savings target, these properties are granted additional time to comply. And lastly, there's the custom alternative compliance option that I'll mention. So this allows property owners to propose alternative approaches to improving the energy efficiency that may not be possible under those existing compliance structure. So DOEE evaluates these proposals on a case-by-case basis and considers their potential to achieve energy savings comparable to or greater than those required by the principal pathways. Next, let's look at how BEPS compliance overlaps with building codes. So first, we'll look at some background information of building energy codes in DC. So what are energy codes? Energy codes are a legal set of requirements that outline the minimum efficiency levels for new and renovated buildings to ensure reductions in building energy use and emissions. So these codes are a subset of various building codes, including those related to fire safety, electrical systems, structural integrity, and plumbing. So it's worth taking the time here to understand building energy codes, because out of all the energy efficiency programs, improved building energy codes and the enforcement of these codes has been shown to make the largest difference in reducing energy use across the building stock of a jurisdiction. So how do energy codes apply to buildings? Energy codes ensure that buildings meet specific energy efficiency standards for various systems. So let's break down how these codes apply to different aspects of a building. First, the building envelope works to reduce heat transfer and energy loss between the interior and exterior of a building. Energy codes establish minimum insulation requirements for floors, ceilings, and walls. And this ensures that buildings are well insulated to retain heat during the winter and stay cool in the summer. Proper insulation minimizes this need for heating and cooling, which leads to significant energy savings. DC's energy codes also include air leakage standards, which ensures buildings are tightly sealed. So this prevents unwanted drafts and air leaks, which can cause temperature inconsistencies and increase the demand on those HVAC systems. Fenestration, including windows, doors, and skylights, is also another aspect regulated by energy codes. So these standards provide guidelines for solar heat gain and insulation performance. So in fact, at Energy Shrink, we do specialize in this area. So our energy modeling consistently finds that building envelopes can make the largest difference at the performance of a building. Next, we have HVAC systems. So energy codes regulate HVAC systems to ensure they operate efficiently while maintaining thermal comfort and indoor air quality. So proper sizing of equipment helps avoid inefficiencies and energy waste. Control systems help optimize performance by adjusting heating, cooling, and ventilation based on occupancy and specific settings. So energy codes also establish ventilation requirements to help balance the indoor air quality with that energy conservation piece. So regular maintenance is also emphasized to keep HVAC systems operating at peak efficiency over time. Next, we have domestic hot water. So energy codes address both the heating and distribution of hot water, requiring water heaters to meet specific efficiency levels. So this includes promoting the use of high efficiency water heaters, such as heat pumps or tankless systems, which heats water only when needed. So energy codes also mandate insulation of hot water pipes. So this helps maintain water temperature during distribution, reducing that need for reheating. Efficient recirculation systems and low flow fixtures also contribute to energy conservation. So these recirculation systems ensure hot water is available when needed without excessive energy use, while low flow fixtures reduce the overall volume of the hot water that is being used. So let's move on to lighting. These standards focus on maximizing energy efficiency while maintaining proper illumination for various spaces. These standards set minimum efficiency requirements for lighting fixtures, and these can include the lamp and the housing for the lamp, like the use of energy efficient technologies such as LEDs. So in addition to efficiency, codes consider lighting quality, ensuring that brightness, color temperature, and color rendering meet the needs of occupants. Also, control systems for lighting and dimming systems help manage the lighting usage and reduce that energy waste as well. There are also standards set for a wide range of other equipment used in buildings. So these regulate common household and commercial devices, such as refrigerators, office electronics, and cooking appliances. So for example, appliances that meet higher efficiency criteria, like those with Energy Star, help reduce energy consumption and help lower utility costs as well. Similarly, efficient cooking devices, such as those induction cooktops, can reduce heat output and cooling demands. And lastly, we are seeing energy codes increasingly promote the use of renewable energy systems, like solar panels and wind turbines, to reduce that reliance on traditional energy sources. So financial incentives such as tax credits and rebates are often offered to promote a greater adoption of these systems. DC offers a very high rate for solar renewable energy credits. Owners can actually earn over $400 per megawatt hour generated from this market at this time. And these high rates typically translate to a paycheck of 2 to 4 years for most rooftop solar systems. These systems also require an assessment of a building's potential for renewable energy, considering roof space, site orientation, and the local climate. Some energy codes set renewable energy targets, which encourages buildings to meet a portion of their energy needs through these clean energy sources. In summary, energy codes help optimize the performance of a building's key systems from insulation to renewable energy, ensuring a more sustainable and efficient structure. Next, we'll look at where these building energy codes come from. So national model energy codes are developed by either the American Society of Heating, Refrigerating, and Air Conditioning Engineers, also known as ASHRAE, or the International Codes Council, or ICC. So ASHRAE develops the Model Commercial Energy Code, Standard 90.1, while the ICC develops the International Energy Conservation Code, or IECC, for both the residential and commercial buildings. Then state or local authorities then adopt one of the national model energy codes, an amendment of the model code, or can develop their own region-specific energy code. And the model code cycle operates continuously, with the development of new codes occurring every 3 years. But states and jurisdictions don't have to follow the same cycle. So this is why states all over the US are at different stages of code adoption. Some have 2019 codes, while some are still on 2012 codes, and there are still states with no energy codes at all. In states that do have energy codes, the adoption date and the effective date of a code may differ. So this is often done to accommodate a grace period during which the previous code can still be utilized. The rationale behind this approach is to account for factors such as different stages of design or construction, the need for stakeholders to familiarize themselves with the new code, and allowing manufacturers time to supply products that comply with the updated standards. The effective date may also be linked to the publication date of a model energy code, and this ensures a reasonable transition period for all involved parties. It's also important to note that a building built to code is actually the worst possible building that you can legally build. So the codes are setting the minimum standards. Therefore, it's advisable to go beyond and over the code requirement, especially with future BEPS cycle compliance in mind. So here we have an overview of the history of DC's building energy codes, leading us to today and the near future. So the first energy codes in DC were actually adopted in 1992, which were updated in 1999, 2004, 2008, and 2014, before the current 2017 codes came into effect in 2020. In parallel, DC also passed several laws related to clean energy and efficiency in the last 2 decades. In 2006, the first DC Green Building Act was passed, and a set of green building standards were proposed. Energy codes were updated in 2008, and at the same time, the district passed the Clean and Affordable Energy Act of 2008. The Clean Energy Act of 2008 was a groundbreaking law that required energy benchmarking for both government and private buildings. In fact, DC was actually the first in the nation to pass this benchmarking law. Government buildings were required to benchmark their energy use annually using the Energy Star Portfolio Manager tool, starting in 2009. The annual benchmarking for private buildings followed that over the next 4 years, starting in 2010. The current code of DC is the 2017 DC Energy Code, which became effective in 2020. Their development started in 2015, so this took about 5 years to develop them and come into effect. At the same time, DC developed an alternative compliance pathway known as Appendix C, which could be used to comply with the code by achieving net zero energy. It was introduced as a voluntary pathway to net zero energy buildings and offered district building owners and developers insight into what the future of building requirements could look like. In fact, Energy Shrink presented Appendix Z requirements in DC on behalf of DOE in 2018. So this calls for design elements that use complementary approaches to achieve net zero energy performance. These include reducing building energy demand for heating, cooling, lighting, and ventilation through the use of passive design and improved envelope performance techniques. Also reducing total building energy consumption through the installation of high efficiency mechanical systems, hot water systems, power systems, and lighting. And lastly, it supplies remaining building energy needs from renewable sources of energy. So note that the Appendix Z code is set to become mandatory for all new construction and for any substantial improvements of covered buildings by the end of 2026, which is only a couple years away. So public buildings are already required to follow Appendix Z, and this is under the Greener Government Buildings Amendment Act of 2022. So it's best to really get familiar with this Appendix Z and expect that we will be building only net zero buildings in DC in the very near future. So where can you find the DC Energy Code? So again, the 2017 DC Energy Conservation Code can be found on the website of the DC Department of Buildings. Appendix Z is part of the code document listed as an appendix there. And the U.S. Department of Energy also provides tools to help check if your project meets your state's building energy codes. So they provide a web page tool for both residential through ResCheck Web and commercial buildings through ComCheck Web. And we can post these in the chat later as well. So the DC Building Energy Code for commercial buildings is structured into 9 key parts, which each address different aspects of building performance and energy efficiency. So the last one here, Appendix C, establishes the alternative compliance path for projects aiming to achieve net zero energy performance. And because it's performance-based, this option encourages those innovative approaches to energy efficiency. So at this point, I'll pass it back off to Smita, who will go more into depth into Appendix C.
Thank you, Kara. Can you hear me all right?
Yes.
Okay, great. I'll have to ask you to move the slides. So before I dive into Appendix Z a little more, a couple of things I wanted to mention. One was that, if some of you may have joined in the last, after we did the introductions for the audience. So if you did, please share your name, organization, and role in the chat so that we know who we are speaking with. And it's really great to see the variety of people who are on the call. I also wanted to mention that Appendix Z is actually going to become the default code for DC, by 2026. So this is something I wanted to highlight for all the listeners, that there is a through line in the entire webinar, in today as well as the next session next week. And that is that the DC laws, the BEPS compliance requirements, and the DC codes are all trying to move DC towards carbon neutrality. So that is what we are really trying to highlight here. There are all these details that get you to that point, and some of these details can feel like very detailed, but each of these pieces is what gets you to carbon neutrality. There's no magic to it. It's just a very systematic approach to looking at each part of the building that contributes to either the demand from the building or the response to that demand using energy systems. And when we think about it methodically, step by step, and attack each of those pieces one by one, we can get to net zero. So with that, I'm going to start going into the requirements for Appendix Z. So this Appendix Z in the DC Building Energy Code provides a framework. So you think of it as a framework that's helping you get to net zero for achieving net zero energy performance in buildings. Right now, it's a voluntary pathway provided as an appendix, as Kara also mentioned. However, it will soon come into force as mandatory. And it's very aligned with the long-term goal of BEPS. So let's see how. Net zero energy buildings are those designed and operated. So the operations is very important here. They are designed and operated to produce as much energy as they consume over the course of a year. So you have a year to show that balance, typically through a combination of passive design, something we've had webinars on in the past, and we can do them again if there's interest, but very, very, very important to focus on the passive design piece. So usually you get to net zero only if you do passive design measures. So it's through a combination of passive design and improved envelope performance techniques, coupled with energy efficient design, renewable energy generation, and energy storage technologies. Appendix Z introduces specific definitions concerning net zero energy compliance, which we'll see shortly. These definitions can vary by jurisdiction. There is also a national definition for net zero being developed. So that's important to pay attention to how your jurisdiction defines net zero. So the appendix applies to new construction projects. Naturally, the codes only kick in when you are building something new and you go to the building department for a permit. And so, or if you're doing major alterations. And this is where there is an overlap with BEPS. So when you're doing major alterations under the existing building code, where the net zero compliance path is chosen, then it kicks in as well. So overall, Appendix Z offers a comprehensive approach to achieving net zero energy performance in buildings. Next slide, please. So this is highlighting the key performance requirements in Appendix Z. There are a lot more details in Appendix Z, but these highlights are, so the minimum performance requirements establish standards for building energy use intensity before incorporating renewable energy generation. So this is really important. The renewable energy, which sometimes people think of as the first step to get to net zero, should really be the last step to take care of the residual energy use. So Appendix Z approaches it the correct way. So the compliance involves meeting the mandatory prescriptive requirements, and the building energy use intensity calculations are crucial in this process. The energy use intensity is measured in source energy units in kBTUs per square foot per year. And the building must demonstrate compliance with the net zero energy target. The way Appendix Z does it is by using a ZEPI score. This is a score that actually has been developed by the New Buildings Institute, and it stands for the Zero Energy Performance Index. And the way it differs from the Energy Star score is that it doesn't compare your building to other buildings in the country and assign you, on a bell curve like the Energy Star score does. Unlike the Energy Star score, the ZEPI score is an absolute scale with two key points. A building with energy use equal to that of an average building in the year 2000 receives a score of 100. And then a building with net zero energy use receives a score of 0. So it's a sloping scale, and depending on where you fall on that scale, you get your score. And in DC, you're required to be equal to or under 30. So it's a linear scale between the 2 points. So if a building uses twice as much energy as an average building that in 2000, it receives a score of 200. And if a building uses half as much energy as the average building, it receives a score of 50. So this simple relationship between the ZEPI scores can be easily understood by code makers, architects, and engineers, as well as non-technical building owners and tenants. So it's designed, the ZEPI scale is positioned to measure buildings that go beyond net zero and can also get a negative score. So if they produce more energy than they consume, they can actually get a negative score. The first commercial office building in Seattle that actually got they did a living building challenge, and they were the first commercial net zero building. They actually produce more energy than they consume because they overestimated the size of the solar panels they would need. Their entire roof is covered in solar panels, but the building is so efficient that it produces more than it consumes, and they have a negative ZEPI score. So for new construction, typically you use predictive modeling to determine the compliance. And that's how it would be for Appendix C. You would use predictive modeling to determine whether you meet the requirements or not. But for existing buildings, it's based on actual performance. So when you're thinking about BEPS compliance and retrofitting your building, it will be looking at your actual bills to determine whether you're compliant or not. So under Appendix Z, the design must demonstrate maximum annual heating and cooling demands. This is really important to understand because this again ties back to the passive measures. If you have a really efficient building envelope, like if your building skin is good, you are going to have reduced heating and cooling demands. And that's what DC is looking for. Because when you have lower demands, you use less energy to meet those demands. So the building design must meet a maximum annual heating demand of 4.2 kBTU per square foot per year and a maximum annual cooling demand of 6.4 kBTU per square foot per year. Now, we are warming and DC is warming. Every decade we are getting much, much hotter, and the number of hotter days are increasing. So I don't know if they'll adjust these numbers as our cooling demands go up. But right now, this is what we are asked for in Appendix C, 6.4 kBTU per square foot per year. So if there are multiple buildings on a site, each building on the site must comply with the thermal energy performance requirements, or the combined demands of all buildings must meet the standards. So you can look at it as with a campus approach as well. A registered design professional is required to be in charge of the building energy simulation to ensure the accuracy in energy modeling. Commissioning of all systems is also required. So this includes building envelope, HVAC, lighting, domestic hot water, and renewable energy systems. all of these must be commissioned. And just in case you're not familiar with the term commissioning, it simply means you hire typically a mechanical engineering firm to go into the building and make sure that your equipment is installed and functioning as intended in the design intent. So that process is called commissioning. Air tightness testing is also required. So a whole building pressurization test is conducted to measure the air tightness of the building envelope. That's how air tightness is tested. You pressurize the building and you see how much leakage is happening. There are residential systems that you might be familiar with, the small blower doors. And there are also very large commercial systems where you use multiple fans to pressurize a space. So, but this is required under Appendix Z to verify compliance with the specified standards. These requirements collectively aim to achieve high energy efficiency levels in buildings before considering renewable energy options. Next slide, please. So now when you get to the renewable energy for the building, your renewable energy for the building, like the total generated renewable energy or consumed renewable energy, must match the building's annual energy use demand, energy use intensity. So there are some acceptable sources for the on-site renewable energy and in Appendix Z. These include PV panels, solar thermal systems, which would be used for hot water, wind turbines. You get really cute small wind turbines now that you can attach to buildings, like one, kWs, small size wind turbines, which actually there are some really interesting shapes as well that you get. So it's not that strange to think about wind turbines on buildings. And you can also use biogas. I just want to make a note here that biogas, globally speaking, is controversial. So I wouldn't recommend considering the use of biogas because combustion still produces emissions. So one would only want to use biogas if you were generating it yourself on site. Then you, instead of venting it, you could, combust it to get renewable energy. But if you had a choice, you would not want to use biogas if possible. On-site combustion of fossil fuel is prohibited in Appendix Z. So that means you cannot actually install systems using natural gas under Appendix Z. It is prohibited. So the only exception is if you are looking at a critical backup system like a generator in a hospital, then it might be allowed. But in normal cases, it is prohibited. That means for cooking, space heating, not allowed to use fossil fuel systems. So it just says fossil fuels, which typically means natural gas, but we may be looking at other options. On-site renewable energy generation is encouraged, and there are actually specific requirements for both on-site and off-site renewable energy procurement. So for off-site procurement, so let's say you don't have enough roof space to cover your renewable energy needs, you can buy off-site renewable energy, and this is called off-site procurement. So this is only allowed from qualified suppliers who meet the DC renewable portfolio standards. So DC actually qualifies suppliers into different tiers, and you have to get your renewable energy from a qualified supplier. So the accepted methods for offsite procurement, there are different ways to buy offsite renewable energy. So these include PPAs, that are power purchase agreements. You can also connect to renewable energy microgrids, which are actually a great way to reduce the load on the electric grid. Or you can participate in low carbon neighborhood thermal energy systems. So these are not very common in the US, but they are being discussed more and more as possible ways to reduce our dependence on the grid. And they are pretty popular in Europe already. So if you are curious about neighborhood thermal energy systems, please look them up. You'll find lots of examples in Europe. The idea is that you have a common system that's producing your heat. Normally it's used for space heating, and providing it through underground network of pipes to individual buildings. So the individual buildings don't have to invest in heating and cooling systems. And when you do it at a larger scale, you actually get more efficiency as well, except there are some losses in distribution. So the systems that we discussed, I'm sure many of you are familiar with. So the PV panels are simply converting sunlight directly into electricity, and they're widely used because of their efficiency, and they can be used on various building types. So when you're installing PV panels, you can directly use the clean energy to power your operations. Solar thermal systems, they are using solar energy to produce heat, and they can be used for water heating or space heating. If you have a hydronic system that is, supplying hot water, it's a little difficult to use that in places like DC because for space heating, because normally in winter we don't get enough sun to provide enough hot water for space heating. But they are particularly effective for reducing energy consumption in water heating applications. So wind turbines, they are just converting kinetic wind energy into electrical power. And although they are less common than solar, they can be an effective renewable energy source. Around DC, a lot of states along the East Coast are installing very large wind systems. So there might be more and more options for procuring wind energy from offsite. And then finally, biogas is energy that's produced from organic waste. And it's usually, there's a specific way you have to produce this energy. It's called anaerobic digestion, that is without oxygen. And this process generates methane, which can be used as a fuel for the electricity generation or heating. But I'm guessing that most of you know that methane itself is a very, very potent greenhouse gas. It's 80 times worse than carbon dioxide. So if it leaks, it can actually contribute to global warming. So we don't really encourage going down this road because of that. Of course, if it is fully combusted, it is only producing carbon dioxide, and which is not as bad, but still not great. So but if you are producing methane anyway, like some kind of process is producing methane, then it makes sense to use that and burn that so that it doesn't get vented into the atmosphere. Next slide, please. So what are the requirements for on-site renewable energy in Appendix C? The code mandates that at least 5% of the building's total energy consumption must be sourced from on-site renewable energy systems. So for buildings that are opting to use solar photovoltaic panels as their primary on-site renewable energy technology, a key requirement is the allocation of a minimum of 25% of the total site area for energy production through solar PV panels. A quarter of your site area should be dedicated for solar PV panels. So a lot of times you need some of that area for your mechanical systems, for landscaping. So please keep this in mind. A minimum of 25% of total site area for energy production through solar PV. And when you're designing the solar PV system and you're designing your site, it makes sense to involve your solar panel installers from the very beginning, because they will want to look at some key factors like the panel orientation, shading, and the roof structure to make sure that the panels can go where you imagine that they might go. Next slide, please. So the code allows for the procurement of renewable energy from offsite sources, like we discussed. They must meet the DC's RPS renewable portfolio standard criteria. These standards include criteria such as minimum percentages of renewable energy. So what percentage of the energy that's coming through those wires is renewable? And then the restrictions on the types of acceptable renewable sources. And there are also requirements for tracking and reporting the renewable energy usage from the suppliers. So that's how they choose their suppliers. And the code outlines several acceptable methods, again, for procuring offsite renewable energy. And, like I mentioned earlier, there's a little bit more detail on those three. So you have to contract with a qualified supplier, and buildings can enter into long-term contracts for a minimum duration of 5 years. So these contracts ensure a stable supply of renewable energy and will typically include terms that align with the RPS requirements. So this provides a predictable and consistent source of renewable energy. It helps the buildings to meet their energy needs, and it also supports the renewable energy markets. So, for the suppliers, it's difficult if their clients are going on and off every year. So they also need stability so that they know they are locked into these contracts and they can procure their renewable energy accordingly. So when you're buying from an offsite supplier, you're getting locked into a 5-year contract at a minimum. You can also connect to the renewable energy microgrid. So when you do this, the microgrids are localized energy systems that generate and distribute renewable energy within a specific area. That's why they're called microgrids. They're like small grids for a certain area. And again, when you connect to a microgrid, buildings benefit from a reliable supply of local renewable energy. And this actually enhances your energy resilience. And this is an important point to keep in mind in this day and age, because we are already seeing cyber attacks on regional transmission grids, which can actually bring the entire grid down. And of course, when we have storms, we lose, thousands of people lose power. So when you tap into a microgrid, you are actually making your building resilient. That is, it can withstand those shocks. So that's microgrids are a really good example of energy resilience. Normally, microgrids are created not by individual building owners, but by larger developers who might be developing a whole area. So you have to be aware of it and look for those opportunities, unless you are a large developer yourself. Okay, and the final one, the thermal energy system, the local thermal energy system. So these are, they can provide heating and cooling, especially if you consider large thermal energy systems that are powered by heat pumps. They can provide both heating and cooling. And so the ideal system would be a heat pump system that is powered by renewable energy, providing heating and cooling to a neighborhood. Like that would be the holy grail. So when you are using, another way to do this is geothermal. So geothermal or solar thermal systems, solar thermal would only provide heating, but geothermal systems can again provide heating and cooling. And a lot of times the heat pumps that I just mentioned are tied into a geothermal system so that it improves the efficiency of the heat pumps themselves. So you have the geothermal pipes supplying the warmer or cooler, depending on the season, water to the heat pump, which is then using that pre-cooled or preheated water, and therefore improving its efficiency and then supplying a whole neighborhood. So this again, when you're connecting into such a system, it's improving the overall energy efficiency of the region and reducing the building's carbon footprint as well. Next slide, please. So this is now another requirement of Appendix Z, which is energy reporting. This is required by Appendix Z. This means come 2026, it's going to be required. So energy metering, monitoring, and reporting is required. to make sure that the buildings track their energy use, production, and reclamation. So that means if you're reclaiming any energy, that also is required to report it. So when you're reporting like this, it involves isolating the load types in the energy distribution systems, installing extra meters and devices and data acquisition systems that you may not have been doing traditionally. And energy displays can also be a part of it, just to help keep track of how much you're producing, how much you're consuming. A lot of buildings use energy displays for that. So all forms of energy delivered to or produced on site must be metered. So considerations for on-site storage options are also required. So if you are producing energy where your equipment does not allow net metering. So many of you may be familiar with net metering. But just in case somebody is not, net metering is where you're producing energy, and if you're producing excess energy that your building is not using, you're allowed to put it back into the grid. But if there are constraints where you're not allowed to put it back into the grid, and actually this is a very real problem because PEPCO, for example, is the electricity provider in DC, and it has a limit on how much you can put back into the grid because it, it can actually upset their distribution system if there's a surge of electricity coming from a building into the grid. So they have set limits on it for their own grid reliability. And to overcome this limitation, buildings can, if they're producing more energy, they can add storage to their sites so that they store that energy and use it later in their building, like let's say at night if you're using solar PV, to avoid putting it into the net metering system and still using that energy later. So that is actually required by Appendix Z in areas where you may not be able to avail of the net metering. So the Appendix Z reporting process involves annual benchmarking, which many buildings are already doing, but it is going to be required for everybody who's falling under Appendix Z. So annual benchmarking and sharing the performance data on energy and water, like the larger buildings in DC are already doing. So BEPS already requires benchmarking for buildings above 25,000 square feet. So now we're in the second cycle that, we've started with the 50,000 and above. They have been reporting. Now we are starting the second cycle of 25,000 square feet and above. And then there'll be a third cycle of 10,000 square feet and above. And then Appendix Z would apply to any commercial new construction. So even if it's smaller than that, if it's new, it's going to be required to do that. So again, all of this is trying to get DC to carbon neutral. So these are all aligned in intent. So owners are obligated to annually benchmark and report energy and water performance using the Energy Star Portfolio Manager tool, which I think more and more people are getting very familiar with. It's a very simple to use tool. We encourage our clients to get familiar with it and try to do it themselves, but we are always here to help. And it also includes renewable energy generation and green power usage inputs into the tool, regardless of square footage. To comply with the reporting requirements, buildings must create an Energy Star account and portfolio manager, and they have to share it with the DC Department of Energy and Environment. And then buildings are required to verify their energy performance within 24 months of occupancy. So you have to start planning ahead, knowing that in 24 months, you're going to have to verify the energy performance. So this verification process involves demonstrating that the building has operated continuously for at least 12 months with at least 90% occupancy, and that its energy consumption does not exceed the energy generated from on-site renewable sources or off-site procured energy. So the verification involves collecting and analyzing the data on energy use, occupancy levels, and renewable energy generation. So it's your bills, your occupancy levels, and renewable energy. So the results are then submitted to the relevant authorities to confirm that the building meets the required performance standards. So for BEPS, so far, it has been the Department of Energy and Environment. For the Appendix C, the code compliance, it may be the Department of General Services, or it may again be the Department of Energy and Environment, or both, or a new agency. This is yet to be determined. So the code official whoever it is, the official that is going to be checking the code compliance, they would consider like abnormal weather or occupancy conditions for deviations from the expected norm. So for example, the COVID pandemic threw all the numbers off. So similarly, if hopefully not, but if there's anything that affects occupancy, unexpected or abnormal weather, those deviations would be considered. So there is room in the code for that. Next slide, please. So, this is where BEPS meets Appendix C, right? So BEPS, like we mentioned, is successively going to get tighter. So, every cycle you can expect to have tighter and tighter regulations. And Appendix Z actually helps you leapfrog that and get all the way to the final intent of BEPS, which is to create zero carbon buildings. One thing that Appendix Z does not yet have, and we might start seeing it in the coming years, is the consideration of emissions from refrigerants. So refrigerants have extremely high emissions. The typical R410A that we use right now in our HVAC systems has a global warming potential, like the warming footprint, 2,000 times greater than carbon dioxide. I'm using round numbers. It's roughly 2,000 times greater than carbon dioxide. So, and we don't yet count those emissions in our energy performance criteria. But that is something that is being discussed very heavily. There are things going on from two directions. One, how do we account for the refrigerant emissions in these calculations? And two, how do we replace these refrigerants so that we don't have to account for these? So there are also low global warming potential, low GWP refrigerants being introduced into the market by law. So it's being attacked from both sides. But you can expect in the coming years to be thinking about your refrigerants in your buildings, which is also another reason why you should be thinking about passive design and reducing your energy demand in the first place, because then you'll need fewer tons of refrigerant and you'll have fewer things to worry about, less GWP to worry about. The other thing that's not in Appendix Z yet is the emissions from construction. So that is also another topic that is very important for new construction, especially. As our buildings get more efficient, the impact from the emissions of new construction becomes an even larger factor in new construction. And that is not yet taken into account in calculations. And there is a large awareness of the impact of that. And there is a push to include that in carbon calculations. So if we truly want to be carbon neutral, these will eventually make their way into the codes. So just something to be mindful of, to start thinking about low carbon refrigerants and low carbon materials. But putting that on, we are talking about Appendix Z, which is coming in 2 years. This may be coming in 6 or 10, I'm not sure. So getting back to the Appendix Z requirements that are imminent, the good news on the energy side is that we don't need new materials or new refrigerants. We already have all the technology that is needed to do net zero buildings. The technology already exists. There are over 700 net zero buildings in the US already. The New Buildings Institute maintains a database. So if you're curious, you can go and look at them. There are a lot of schools which actually lend themselves very well to net zero buildings because they have a large roof area. You can install a lot of solar panels, and you can, there's a lot of envelope area to improve as well. So many off-the-shelf technologies available today surpass code requirements. So like Kara mentioned, meeting code is like getting a D in your class, in your class score. So it's like the minimum passing mark. So you really want to see how you can get an A in your building requirements. So for example, high efficiency HVAC systems, advanced insulation materials, smart lighting controls, all these can significantly improve your energy performance, reduce your operating costs, and provide greater comfort for occupants. So in our work, we do a lot of energy modeling, and I want to emphasize this once again. We constantly see that air tightness is the number one way you can reduce your energy demand. So if you are building something new, you really want to start with making sure that you're making your building airtight. And people don't realize, but air actually flows through gypsum board, through brick, and through cement. So the way to make your building airtight is you have to use materials that have low permeability, and there are special materials like certain paints, metal panels. There are also special air barriers you get. But once you get familiar with the different technologies, you have to make sure that you specify that in your building and make your building airtight. If you start with that, you're already cutting out 20 to 30% of your heating and cooling needs. I mean, it makes a huge difference. So then you compare that with, insulation, and you're halfway to the goal already. So highly, highly recommend looking at your envelope, air tightness, insulation, windows. If you have the skin right, you are halfway there. So as the building energy performance standards evolve towards net zero targets, early adoption of higher standards, such as those outlined in Appendix C already, can save money for the clients in the long run. So it can be a little bit of a hard sell to go beyond code, but if you can show your client the life cycle cost analysis, the LCCA, which is becoming more popular, New York is already requiring an LCCA in their projects. You can actually show them how they'll save a lot of money in the long run, so they can put that money in upfront. Unless they are developing and flipping properties, they should be interested in this if they're holding onto the properties. So this proactive approach helps to avoid incremental improvements and ensures future compliance with BEPS cycles. And that is another way to encourage your clients by telling them that, look, if you don't invest now, you might be liable for fines in 5 years. So this can, being prepared for it and showing that your property is already ready for future cycles of BEPS can increase the long-term property value. So buildings that exceed code requirements also qualify for green certifications, and there are all kinds of tax incentives available right now that can also enhance their value. So the performance path for the BEPS compliance offers flexibility in achieving the energy efficiency goals. Like we saw, there are multiple ways you can get there. And the approach of using the performance path over prescriptive is the most aligned with Appendix Z. So in contrast, the prescriptive path provides specific measurement technologies that must be implemented. So even though that can seem a little more straightforward, it is actually less flexible, as it requires picking from predefined solutions rather than allowing a tailored approach. So you have to look at whether you can afford to bring in a building consultant like ourselves into the picture to do a performance path. Like, it requires energy modeling and thinking through your various options and seeing how much each option costs and what is the most cost-effective way to get to your energy performance, required energy performance. It is ideal, but not every project has the budget for it. So if there is absolutely no budget to bring in an energy modeling consultant to think through these different options in the beginning, then it makes sense to look at the prescriptive path, because the Department of Energy has already done their analysis to ensure that most buildings, if they follow that menu of options, will fall into the acceptable range of energy performance. So that's how you have to make some decisions about what to pick. Next slide, please. Okay, so the BEPS and energy codes fitting together, right? So once a new building is constructed, it immediately falls under the purview of BEPS regulations. So for commercial office buildings constructed in compliance with the current building codes, which are the 2017 codes, there is a high likelihood of meeting the requirements for the initial BEPS period. However, it's not guaranteed depending on how you met the current code. And while the new construction may initially align with the BEPS standards, buildings that are only designed to meet the minimum code requirements will encounter challenges in meeting the more stringent long-term criteria as the BEPS standards evolve and become progressively demanding over time. So this is something to keep in mind. So meticulous planning and consideration during the design phase are crucial to ensure that your building not only complies with the current DC energy code, but also remains compliant with evolving BEPS standards throughout the operational lifespan of the building. And something to keep in mind when you're doing this also is, if you kick the can down the road, like let's say you say, okay, when the next compliance cycle comes in 5 years, we'll do it then. In the meantime, you are contributing to the cumulative emissions in DC. So if you can avoid emitting those carbon molecules into the air in those 5 years, you're actually going to be doing the world a favor. So that's a big reason to consider these things from the beginning. So these points highlight the shift from traditional building codes to performance-based standards. So we are slowly going towards performance-based standards, right? So your building energy performance standards extend beyond the scope of traditional building codes by focusing on the energy use of the buildings. The traditional building codes say, put this much R value, put this efficiency of HVAC. And these codes are saying you cannot use more than X kBTU per square foot. So it's about how your building is ultimately performing after it is occupied. So while the building code sets standards for energy efficient design and construction, BEPS is addressing the actual energy consumption that occurs once the building is in use, including the aspects that are not covered by codes. Next slide, please. So what is not covered by codes? This is a really, really important aspect to focus on. And this is the unregulated code loads. Because actually, if you look at a pie chart, I apologize, I don't have a pie chart up here to show you, but there are unregulated loads in buildings, which are your plug loads. They are increasing, like nationwide, you're seeing this trend that your unregulated loads are increasing as a piece of the pie over the last few years, last few decades. Both residential and commercial buildings are seeing a very high piece of the pie as unregulated loads. It can be 40 to 50% of the energy used in a building can be unregulated loads. So they are a crucial piece in achieving your BEPS compliance because they represent a substantial portion of the building's energy consumption. So unregulated loads refer to energy consumption from equipment and plug loads that are not directly controlled or specified by building codes. So this can include various types of office equipment, appliances, and other plug-in devices that significantly impact the building's overall energy use. So this is your printers, your fax machines. This can be, all the new devices that keep getting invented every year. So unlike your regulated systems, like your HVAC and lighting are now regulated, these loads are often less controlled, and they can vary widely based on the occupancy and equipment choices. And because these loads are not typically regulated by building codes, their impact on energy performance must be managed through additional strategies to meet the BEPS requirements. So to address this post-occupancy energy use, design teams can incorporate strategies such as specifying energy efficient equipment implementing smart controls. So you get, smart strips that will turn things off at a certain time, or they can be tied to occupancy sensors where if you're not in the room, it can turn off your equipment. And also designing flexible spaces that can adapt to changing usage patterns. So we are seeing this all over DC right now. Office buildings are emptying, and there is a trend towards converting them to multifamily. And a lot of buildings are having trouble because they are not as easily able to do that. So this can actually, if you are more designing more flexibly in the first place, it can actually help to manage, strangely enough, your energy use and optimizing energy use because you're building in that flexibility into the building. And keeping in mind that today this is an apartment, tomorrow it may be an office or vice versa. So in addition, your building management systems that monitor and optimize energy use can be used to help in managing your unregulated loads effectively. So it's worth noting that the Energy Star score that you're getting in the BEPS program, you're required to use the Energy Star Portfolio Manager. That takes into account not only your regulated systems that are coming under code, but also your unregulated loads, because it's just looking at your total energy use and the occupancy patterns. So the BEPS is factoring in both occupancy patterns and equipment usage as part of its performance evaluation. And buildings with high occupancy rates and varied equipment use may experience different energy demands, which will be reflected in their Energy Star score. Finally, I'm going to, this is my final slide for today. So we are looking at thinking beyond code and thinking about it in terms of building energy performance. Building energy performance standards require that we look beyond the current code to regulate building performance. And design teams must consider long-term performance and BEP cycles in initial budgeting and design. Because once Appendix Z is in force, it will become much easier for the new construction to comply with BEPS. So it is a voluntary code right now. Consider making it your de facto code that you're aspiring to comply with already. Thank you. That's all I have for today. With that, we will take questions. Apologies. So the first question, and I love this question because this is exactly part 2 of our session next week, same time. The question is, what is the definition of significant renovations that trigger compliance with codes and performance standards? That is exactly what we'll be discussing next week. So please join us next week at the same time and we'll get into this. It's a longer list. And we have actually interviewed the Department of Buildings as well. So we learned some really interesting nuggets from them on where people are typically the applications that are coming into the Department of Buildings, the places where they are commonly showing issues. So we'll be covering all of that next week. So one question I have is, will we get a copy of the slides? Yes, we can provide a copy of the slides, sure. Any other questions? So one question from Abdullah Osman is, what incentives or financing will be available for owners to meet these requirements? This is a great question. Actually, we've been, so we work both in DC and Maryland, and we find a very interesting difference between the two, that in Maryland, you have a lot of carrots, and in DC, you have a lot of sticks. So I don't know that you will have a lot of incentives or financing available from DC for owners to meet these requirements. But of course, there is the IRA. The IRA tax incentives are there from the federal level. If you are a public sector building owner, so like if you are developing buildings for the public sector, the DOE SCEP program, so that is the community energy, it's the state and community energy program, will provide free technical assistance for public sector buildings. And they are actually putting that into place. We are also part of the team. Hopefully that'll come through very soon. But that would be a place to get free technical assistance, but that's not for private owners. If you are operating in Maryland, there is a lot of financial assistance available from the Montgomery County Green Bank and the Maryland Energy Administration. DC has the Green Bank that provides, if you are developing green projects, you can get favorable loan terms from the DC Green Bank. And actually, if Mark is still online, DC SEU has incentives available for particular performance programs, like performance-based programs, and some incentives for certain widgets. So look up DC SEU green building programs. I'm not sure if they run out of funding. So their funding cycle starts in October and goes until the September of the next year. Sometimes they run out of funding on certain things. And their incentives are not huge, but they do help. There is also a slate of programs in front of the DC Public Service Commission. We are actually advising the Public Service Commission on some of this work right now that's going on related to these programs. That will be offered by PEPCO and Washington Gas. I'm not sure how long it'll take to start getting approved because it's a slow and very contentious process. But there will be incentive programs available through PEPCO and Washington Gas in the near future for many of these upgrades. Again, the next question is somewhat connected. It says, any guidance on financing compliance projects? So like I mentioned, there is funding available for certain upgrades. In Montgomery County, you can actually get funding for the benchmarking compliance also. But we are not seeing that in DC. You do have to pay for benchmarking compliance, and unless you do it yourself. Yeah, I mean, it's really not hard to do. And if you have the staff, the capability, it's designed to be user-friendly. So I encourage people to try and do it themselves. We work very hard for our clients on their benchmarking, and we don't charge a lot of money. So it's not like a money-making stream of work for us, but we are always here to help if anybody needs help with benchmarking in DC. What else could be used? Is Mark on the line? No. Because I was wondering if Mark Bryan of DCSU or if there's anybody else here on online from the DC government that has other ideas for financing. I would love for you to just unmute yourself and jump in. Any other questions? Actually, financing is a very, very important piece of it. And there is a lot of discussion on how we can finance this. So also keep your eyes open for new ways of financing. One very good resource for looking for financing options is the website of the Institute for Market Transformation. They've created a website called the Building Innovation Hub. So if you look for, there are multiple building innovation hubs across the US, and DC's is, so you have to look for the DC Building Innovation Hub. Under that, you will find information on financing. So whatever I just mentioned, all of those resources are mentioned on the Building Innovation Hub. And if anything new comes up, it will get listed there. So I would say bookmark that resource as your go-to resource for learning about financing options in DC. One trend that I've seen in, Massachusetts, New York, DC, people are opting for what is called braided financing. So what essentially that means is that you don't just look at one source for financing, but you braid multiple sources of financing. So there are the federal funds, there are the tax credits, then there are the state and local funding options. And sometimes you can see grants that are available. And so you can, look at, sometimes you can leverage one to get the other. So if you have, if you lower your costs already using one type of financing, you can use that to leverage a new type of financing. But yeah, I'll put in this chat here. Let me just look up the link to the Building Innovation Hub and I'll put it in the chat. On this website, on the main page itself, there's a big box that says find financing, and that'll show you all the different ways you can finance your projects. So it looks like one of PEPCO's programs is already live, the Income Eligible Multifamily Program. And there's a new program from ICAST that is a brand new program, which is called the One Stop Shop Program to meet energy improvement needs of both market rate and affordable housing. All right, if there are no more questions, we can wrap up here. Kara, do you have anything you would like to add?
Can everyone hear me?
You're unmuted now. Yeah.
Yeah, thank you everyone for coming out today, and we'll be doing this again next week, same time. And let us know if you don't, or that Zoom link that hasn't been sent out yet, correct, Smita? That might be something.
I'll have to check with DCSEU.
Okay.
They're the ones
If
who
anyone
sent-
needs that, we can definitely get that to you all.
Absolutely. Yeah.
So, and the slide deck, we can clean that up and send that out to whoever is requesting.
Thank you for your attendance. All right.